Yeah, we're going to talk about those points. Those are not actually, we're not going to practice it in lab because these are just points that we need to skim. We don't need to go through deep, just in case you get it in the exam or just for your own knowledge. Okay. So Amazon Neptune, the purpose is graph database, like relationship. Just understand this. If you find a question talking about relationships, connections, or graphs, basically the answer is Neptune. Okay, works with highly connected data. Its use case is social networking, social networks, fraud detection, recommendation engine, knowledge graph. Etc. Tech detail, we have supports Gremlin and Sphere, optimized for graphers. So just understand this. If you saw relationship, connections, and graphs in the question, basically most likely it's Neptune. Okay, Amazon Neptune. It's a service. And Amazon Document DB is NoSQL document database. We MongoDB compatible and JSON like data storage. Okay, the idea is JSON like data storage. Use case content management system with catalogs, user profile. So basically, it's compatible with MongoDB APIs, fully managed, no patching. So if an exam you saw like someone saying like if you saw a question MongoDB on AWS, basically it's document DB. Okay, so no SQL document database. So similar to MongoDB, document DB. Amazon Keyspace. This is managed Apache Cassandra. Wide columns, no SQL database. Use cases, high write throughput, app, apps, IoT data, time series data, serverless Cassandra scales automatically. If you see a question about Cassandra, then it's most likely key spaces. Just understand this. And security, AWS Cloud HSM, basically this is a dedicated hardware security module. The key idea is you control encryption keys fully. Use case, regulatory compliance like banking and strict key ownership requirements. And the difference versus KMS, basically KMS is AWS managed or can be AWS managed or shared. Cloud HSM equals to dedicated hardware. Okay. Basically, it's a dedicated hardware. See, this is the difference. KMS is just this is the difference. A single tenant hardware for keys. Basically, it's cloud HSM. Just remember that one. And AWS Audit Manager automates audit evidence collection. Okay, helps with compliance audit. Use case in HIPAA, GDDR, evidence tracking. What it does collects logs basically, maps to compliance frameworks, prepares for audit, collects evidence, audit manager basically. And artifact access AWS compliance reports, download AWS certification, uh, access AWS compliance reports basically, like ISO certification, SOC report. It does not monitor anything; it just provides documents. If question says download AWS compliance report, then artifact. Use artifact. For miscellaneous services, we have Amazon Macy. This is used to find sensitive data, PPI, PIA. Use ML to scan S3, for example. Find credit card, SSN, personal data. Use cases for data security and maintenance, compliance. So sensitive data in S3, Macy. Amazon Detective, we have to investigate security incidents, analyze suspicious activities. Works with Guard Cloud Trail or Guard Duty, root cause analysis, security investigation. To investigate security issues, the detective detects threats like Guard Duty. So this is it. Amazon Detective basically investigates security incidents. It works with Guard Duty and Cloud Trail. AWS Control Tower. This is multi-account management. Sets up and governs AWS accounts, basically. Landing zone setup, guardrail, policy, centralized governance, use case, large organization, multi-account setup, manage multiple accounts, AWS accounts easily. This is why what we call by control tower, why we use control tower basically. That's enough bit for us. Amazon Open Search Service, search and analytics engine, logs analysis and search, basically log analytics from elk stack or full text search and stuff like that. Search log analytic dashboard, basically. That's what Open Search Service is. And AWS application migration service. This is lift and shift migration. Moves server to AWS with minimal change. Basically. How it works, replicates servers and launch them to in AWS. Use case, move servers to AWS with minimal change. Migrate servers as is. Application migration service. Okay. So super quick comparison. If you see graphs and relationship, the answer is Neptune. You see MongoDB, it's DocumentDB, Cassandra, it's Keyspace. CloudSim is dedicated encryption hardware, audit manager, audit evidence, artifact, downloading compliance reports, Macy, sensitive data in S3, detective, investigates threats, control town, multi-account governance, open search, log and search, and VM. Okay, we're going to review all the AWS concepts that we studied, and this are based on the list of questions that appear in the exam. Basically, I got a dump from AWS Solution Architect exam. Okay, so it has like around 1,000 questions. If you noticed here, I mentioned Q1. Yeah, so I uh, I I made a list with the uh, on the topics that are actually appearing in the exams, the kind of questions that we get in the questions in the exams, right? Also, I mentioned under each topic, like which questions, how many questions. You see here, question, it appears in question 4, 42, 72, all this questions, all about this stuff. Okay, that's the idea. Okay, so we're going to go through all this. Okay, and to be familiar with the how the question, to be able to answer questions on the exam. So this is useful actually for us. So let's start with S3 acceleration and multi-part uploads. Okay, for fast long distance uploads to a single S3 bucket from global sites. Okay, so basically, let's say you want a fast and long distance uploads to to a single S3 bucket from global sites. You can use transfer acceleration or multi-part uploads and multi-part uploads. Okay, so yeah, so let's try to understand the difference of both. Okay, so we can actually uh, get an idea because I don't want to go through it fast. We have to able to understand at least some of its concepts here. Uh, no, let's mention transfer acceleration and multi-part upload. Yeah, I think there is an issue with my mouse actually, but that's fine. Let's just type here S3 and multi-part upload. Let's see the difference between them. So S3 acceleration and multi-part are both AWS S3 features designed to speed up file uploads, but they function differently. S3 transfer acceleration uses AWS global network of edge location to reduce latency over long distance. while multi-part upload divides large files into smaller parts for parallel upload. They're often used together for maximum performance. So we know that both of them are used to speed up data transmission over long distance, right? The transfer acceleration, it's best for plans far from S3 bucket region and large file uploads. Okay. Multipart is best for file larger than 100 MB with mandatory usage for files of over 5 GB. Okay. Yeah. So basically, they are used together. Basically, to use multi-part upload for large files greater than 5 GB and turn on S3 if they are on different geographical locations. So, second question is S3 and intelligent tiering. S3 intelligent tiering is best for unpredictable or changing access patterns to minimize costs. Okay, this we know about it. We've talked about it also. What's intelligent tiering? Basically, it decides. Sometimes, let's say you have data inside an S3 bucket, and sometimes you're frequently accessing this data, but sometimes you're not accessing it for a long time, right? So it's unpredictable, right? So the access pattern is changing. So yeah. So this time we allow you, if you configure S3 intelligent tiering, it will decide by itself whether because since it's unpredictable access patterns, okay, S3 intelligent tiering handles whether it handles this stuff for you, okay, whether yeah whether it will transfer it to infrequent access or glacier deep archive, it will decide this stuff. S3 standard IA or infrequent access for data. Yeah, keep in mind about this question actually. See, you will get questions related to S3 intelligent tiering. Like I got one, two, three, four, five questions. So we have to understand this S3 intelligent tiering. S3 standard IA, it's used for data access less frequently, right? But needing immediate access. Okay, so this is infrequent access. Infrequent access means it's access less frequency, but it needs immediate access. Okay, that's the reason we're keeping it in frequent access. We're not moving it to Glacier, right? Glacier is you because Glacier will take time to retrieve to get to access it, right? The retrieval, yeah, it takes hours. So it's S3 Glacier Deep Archive, it's cheapest storage, okay, for long-term archival over 1 year with retrieval in 1 hour, in hours. Sorry. You see, that's the difference between infrequent access and Glacier. Glacier is cheap, yes, but it takes hours to retrieve. Okay, but infrequent access, you receive it immediately. So that's why you keep it in infrequent access. So again, see one, two, three, four. Four questions I received in the exam, like that are related to S3 standard IA. Same thing with Glacier, Deep Archive. We got one, two, three, four, five, six, seven questions. See the frequency of the number of questions that we receive from S3. Yeah, so we have to actually understand this one. S3 lifecycle policy. This automates transition data between storage tiers, like standard to infrequent access or to Glacier. Like you can add this lifecycle policy in S3 bucket. Okay, like you can automate the transition. Like sometimes, like when let's say you have a data in your S3 bucket. Okay. After some time, you notice that this data is actually infrequent access. Like it's not frequently accessed. Sometimes access is less frequent. So where can you move it? You move it to standard infrequent access, right? Okay. So, and then let's say this data it hasn't been accessed at all for 1 year, like for a long time, like 60, 90 days. Okay. Then you have to move it to S3 deep glacier, right? Because it's cheapest, right? So all this you don't have to do it manually. You can just specify a life cycle policy, and it will automate this process for you. Okay. So here we have how many questions we got? We got against for life cycle policies. One, two, three, four, five, six, seven, eight, nine. 9 questions. Okay, so this is very important. And we have S3 object locks. S3 object lock compliance mode. Okay, this prevents deletion or overwriting for a set period. Okay, the benefit of this is actually it prevents deleting or overwriting for specified period. Okay, uh, yeah. So object lock is actually yeah. So we've talked about object locks as well. So we've said that in object locks we have yeah we have compliance mode and governance mode I think. Yeah. So we use compliance mode. Okay, if you select if you enable object lock, that means you can set a period, okay, like 1 day or something. Then in this period, it will prevent someone from deleting or overriding the for the set period. So this is actually important because we are using Q5. We got one, two, three, four, five, six, seven. 7 questions total. Okay, so we need to understand this as well. And we have S3 pre-signed URL. We said this is like temporary URLs, allows temporary secure access to private objects. Okay, that's pre-signed URL. Allows temporary and secure access to private objects. Okay, so yeah, let's say you put your S3 bucket private and you don't want to put it public. You don't want everyone to access this S3 bucket. You just want to allow someone to just access this bucket. You have access to this bucket temporarily. So you can just make a pre-signed URL, share it to them, and they will do that. They will have access to it. S3 batch operation and inventory encrypts existing object at scale. Okay, so it encrypts S3 batch operation and inventory encrypts existing objects at scale. Yeah, yeah. You this is one question. So so this was all about S3 actually. Okay, so S3 itself has a lot of questions. Okay, most of the questions that you saw are basically from, if you noticed, from S3, right? So all of this we've talked about it. We've talked about this one. Okay, I think in details even. So I don't want to go through each one, but if you want, I can do one thing. I can just go to here, go here, and open this one. Just show you briefly, like at a high level, exactly where we can find this, just at a high level. Yeah, we have S3 transfer acceleration and multi-part upload. I think this one you can find it in S3 bucket. S3 bucket here. You go to S3 here. Choose any bucket. Metadata. You can find it in properties maybe.
this is transfer acceleration. Use accelerated engine for faster data transfer. That's the purpose of transfer acceleration. Can you read this one? It's just a matter of clicking this one. That's it. So accelerated endpoint you have here. Use the accelerated endpoint for faster data transfer, which will incur additional fee. So they gave us here additional endpoints. This is because I don't have access actually. Uh, so that's the idea of S3 transfer acceleration and S3 intelligent tiering. We've talked about this as well. S3 intelligent tiering is just you go to property. We have intelligent tiering here, right? This is intelligent tiering archive. Okay, you can create the configuration here. Okay, you can say configuration here. Add this, enable. Uh, you can add archive rule here. Keep archive rules, but you would have to like here. You can say day until transition to the archive access tier. So you can say like 90 here is equal to whole number greater than or equal to 90 days. Okay, deep access archive. Here you can mention 180. So when I click create configuration name, let's just name it here over and yeah, okay. So what this does is basically I'm saying access archive access tier until transition to deep archive. Okay, so these two are actually two different things. We have deep archive and archive. So store the intelligent tiering class to tear down the archive class tier or deep archive, which is optimized for objects that will rarely be accessed. Deep archives is for basically objects that are rarely accessed for a long period of time. Okay, okay. Uh, and we have here intelligent tiering. Yeah, yeah. In addition to this three tier, S3 intelligent tier offers two optional archive access tiers. We have this one, have access asynchronously, object not being accessed for minimum 90 days. You can specify this one. And so we have also this two, frequent access and infrequent access and active instant access.
So we can do that here, and we can do more here actually. Yeah, that's can tear down this one. So regarding this one, we said yeah, and yeah. So intelligent tiering, uh, free by default it's going to be frequent access, and after 3 days, it's going to move to infrequent access. This is automatic. We don't need to configure anything, and then we only configure the last two, which is archive and deep archive, right? Which is 90 days and 180 days. So we have already talked about this. ClaShare, the ClaShare is basically deep archive. We've seen that one. Lifecycle policies, all the stuff we finished. Object loop, lifecycle policies, all this we've already done it, but we can do it from here, like lifecycle policies. You are going to this is object log basically. Store object using right ones. You just edit it, just enable it from here. That's all. No, but that's not all actually. You have to mention the retention, default retention. So how long you need to protect this one. Okay. Use compliance mode. Let's say 1 day. Okay. For 1 day or for 1 year or something like that. So you can enable, you can do that. Okay, you can save change. That's all it takes. That's all how you can do that. Very simple. And when we talk about lifecycle configuration, this is lifecycle configuration. You can create lifecycle configuration here. And yeah, this is where you can add lifecycle rules here, rule name, and you can specify the object size if you need, but you don't. Lifecycle rule actions. Choose the action you want to perform. Okay, let's say you want to transition current version of object between storage classes. Let's say this is what we need, right? We want to automate the process. By default, okay, so let's say choose the storage class transition. So standard infrequent access. So by default, I want to make it if someone didn't access this object, okay, after the, for 3 days, for 30 days, sorry, from the object creation time, then it has to be moved to standard intelligent IA. Okay, now I'm going to make another one. If let's say, what else we have? If and then let's say I want to transfer it to deep archive. Okay, I can do that to ClaShare after, I can say after 180 days or something. Okay, just transfer it directly. Okay, and see it's saying here after 0 object included, object move day 30, object move to standard IO, day 180 object moves to ClaShare. So I can just create rules like this, mention the name, the rule name, and that's all. Like that's how we can configure. This one's pretty straightforward. Okay, and I think this is enough for now. Let's just move on to the next topic, which is EBS. EBS is elastic block storage. This is like storage, basically, like a hard disk for EC2 instance, basically. We've talked about this as well. Provisioned input outputs. Yes. For consistent high performance DB workloads. Okay. Example, it has to be greater than 20,000. No. Yeah. 20,000 IOPS. Okay. That's the question basically. Question 39 and 394. I have the yeah 394 provisions IOPS and general purpose SSD GP3, and it's cost effective for most workload. So basically allows independent IOPS provisioning. Okay, and it's also it's available in three questions. And EBS snapshot, this is like backup. We talked about backup EBS volume. Use fast snapshots to restore to minimize initialization latency for clones. Okay, there's three things. So now we go to EBS. So basically, we said the IOPS is basically the amount of reads and writes per second the storage can handle per second. That's IOPS. So if you have like a database inside this EC2 instance, or you have a DB workload or high performance that requires a lot of reads and writes, then you it's better to increase the IOPS to up to greater than make it greater than 20,000 basically. Okay. If no, leave it at 3,000. So let me show you an example here. One second. We have to go here. Okay, you can go to EBS and volumes here. You can choose one here, and you can modify the volume here, and you can just change this IOPS. Right now, by default, it's going to be 3,000. Okay, the maximum is 80,000. Like based on your workload, this can be increased. You make it 20,000, greater than 20,000. Let's say if you have high volume. Throughput is actually the how much data is transferred at one time. Like if you have large data, one large data, you can increase this one. Okay. Yeah. And the next is actually general purpose SSD, which is the default GP3. It's cost effective for most workload because it allows actually independent IOPS and provisioning. So I think yeah, this is what we are using here actually. And general purpose, this you can see it when you try to go ahead and create a new instance, for example. You can see it here. We have general purpose. When if you go to storage here, for example, you can if you go to advanced, and you will see here. See, by default it's general purpose SSD GP3. Okay, gives you the details for you here. It's the default SSD GP3. So the reason to use this one is actually because it gives you independent provisioning for the IOPS and stuff. It can go up, you can increase, you can decrease. EBS snapshots basically backup volume but faster. There's an option called fast snapshot restore. You can go to EC2 here, or you can go to EBS here, volumes, or snapshots here. Set that snapshot. You can select any snapshot here. You can right click, you can go to snapshot settings. You can click manage fast snapshot restore. Okay, you can choose the availability zone. Okay, and enable. Note that this will cost money. It will be built per minute, so I'm not going to enable it. But the idea snapshot that are enabled for fast snapshot restore enables you to restore volume that are fully initialized at creation. So it makes it faster. Okay. So EFS, we said this is a shared, it's like a shared storage. Okay. We have shared POSIX storage for Linux. Uses for shared scalable, highly available storage for Linux instance across availability zones. And EFS standard IA lifecycle policy to move infrequent data to lower cost tier. This has one question. So this one has a lot of questions. One second. Okay. So we can go ahead and continue. Like we were saying that about EFS, EFS basically it's like a shared storage, okay, for your EC2 instance. It's elastic and it's shared POSIX storage for Linux. POSIX means just how Linux handles file systems, basically. That's what POSIX means. Just think of Linux, basically. For Linux, yeah. So use EFS for shared, scalable, highly available storage for Linux instances across availability zones. Okay, yeah. This is the benefit of EFS. Okay, and it comes up a lot in the questions. You see one, two, three, four, five, six, seven. 7 questions we've got related to POSIX, basically. And EFS standard IA, this is a lifecycle policy to move infrequent data to lower cost steering. Okay, so yeah, this we have one question. Okay, just remember that the EFS is used for Linux, POSIX, sometimes they call it POSIX here, and it's shared storage. And FSX is, we have FSX, the concept of FSX is actually similar with the EFS. The difference is FSX can also work with Windows file server. Okay, FSX for Windows file server, it works with Windows environment, shared Windows SMB storage, and multi availability zone, integrates with Active Directory. Okay, this has a lot of questions. Okay, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 questions, basically. Okay, so it's very important. FSX for Windows file server. Okay, this is the same idea with the EFS, but it's used for Windows environment. For Windows file server, Active Directory, it works with that. Multiple availability zone integrates with Active Directory. Okay. FSX for Lustri, basically this is high performance, low latency shared storage for HPC or Linux workloads. Okay, for high performance, low latency shared storage, we have to, if you see any of this, if you see this together, basically it means it's FSX for Lustri, okay, or HPC Linux workload. Okay, so that's the idea. Okay, and FSX for NetApp on top. This is multi-protocol, NFS and SMB access, low latency, uses SnapMirror for DR. So this is used for enterprise. Okay, NetApp on top, it works for both Windows and Linux. It is used for enterprise, for big enterprise shared storage. Okay, has multiple protocol. Also, you see NFS is for means Linux, SMB with Windows access, low latency, and stuff. Just keep in mind this one. Okay, this we haven't talked about it, but keep it. Now we just finished it, so you can find it here. Actually, you can just type FSX here, and this is FSX. Okay, you can makes it easy. Launch popular file systems. You can choose between these 4 options, right? We have Net on top, which is used for enterprise shared storage, and we have OpenZFS. This is new, it's effective ZFS standard. We have for Windows file server, this one, and yeah, broadly accessible from Windows, Linux, whatever. Click next. You can create, you can choose if you want multiple availability zone, the name, the SSD, the capacity you need. You can choose the VPS, the subnets, standby subnets. All this, if you have AWS managed Active Directory, you can just check and you can create or standard create here. Yeah, so this is the idea of FFS. Just understanding the concept would be useful. And we have storage gateway. Storage gateway is basically S3 file gateway extend on-premise NFS and SMB to S3. Yeah, we've talked about storage file gateway. Okay, it extends the on-premises NFS and SMB to S3. Yeah, let's say you want to transfer low latency cache for recent files. Okay, that's the benefit of S3 file gateway. Okay, volume gateway, it's cached, stored, iSCSI block storage. Cached mode keeps hot data on premises, cold data on S3. Okay, the difference between these two is actually that S3 file gateway, it's it just keeps the recent the cache, the recent files, okay, and moves everything to the S3, extends the on-premises FNB. But volume gateway cached mode keeps hot data on, on premises, the recently accessed data, okay, uh, and cold data to S3, okay. And tape gateway replaces physical backup tapes with virtual tapes in S3 share. Okay, yeah, use it basically. If you use virtual tapes, it means tape gateway. So, but we don't. I don't want to skip through it. So I prefer actually if we go ahead and just compare it one time, just so we can see. We have to know the difference between S3 detailed file gateway versus volume gateway. Tape gateway we already know. The main difference is that is the storage interface and how data is stored in the cloud. S3 file gateway is for file-based access, where each file maps directly to an object in S3, while volume gateway provide block-level storage via iSCSI. So file storage, okay. NFC files are stored as native S3 objects. Local cache, yes, but recent files only. And file sharing, content report that link. So everything we store in S3, uh, everything we store, we write to the gateway is going to S3 bucket. Okay, volume gateway is block storage. This is the difference. Use volume and disks. Use iSCSI. Okay, data is stored in S3 as EBS snapshots. Okay, full. You can have full cache or partial cache. Yeah. Yeah, that's the difference between both. Okay, just know that volume gateway is block storage and file gateway is file storage. And yeah, and data transfer and migration. So AWS snapshot, this is a snowball edge. This is best for petabyte scale offline transfers, minimal bandwidth use. So this question actually has like 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 questions I got from this one, from this topic. So we have to just know one thing about AWS Snowball Edge. It means that if you have, let's say, petabyte scale of data, like a lot of storage, like let's say terabytes of data. Okay, and you want to your S3, you want to move it, transfer it to some S3 bucket. Okay, and you don't want you have minimal, you want to use minimal bandwidth. Okay, and then then you should use Snowball. Basically, they will send someone from Amazon, pick up your data physically and transfer it there. AWS Data Sync automates, accelerates online data transfer to AWS. This also has a lot of questions. 1, 2, 3, 4, 5, 6, 7, 8. Same, eight questions here. Data Sync automates and accelerates online data transfers. Okay. AWS Direct Connect, dedicated private network connection for consistent, low latency, high throughput. Okay. This all these three are used for data transfer and migration. And we've talked about Snowball, and data sync is just it's supposed to speed up online data transfer and automate it. Okay, and direct connect is the dedicated private network connection for consistent low latency, high throughput. This stuff, yeah. So we can go here and go to uh, this is data sync. Okay, simplifies, automates, accelerates moving data. Just click this one here. Yeah. So how it works to transfer data between on-premises or other cloud storage, AWS, deploy an agent, deploy the data sync agent associated with your AWS account, transfer data between AWS storage within the same AWS account, create a task by specifying the location of your data source and destination, simplifies, automates transfer, moves data faster, reduce operational costs. Data migration is used for data migration, archiving cold data, data protection. Choose the data transfer you want to set up between on-premises storage and AWS, between other cloud and AWS, between AWS storage class services. So we can choose from create a new location, location type, let's say that you want to transfer data from. I want to transfer the data from, no, I must have chosen the, you can go back here, create the task, okay, no, this is because I chose on-premises storage and to AWS. Let's see what I get if I choose this one. It's actually the same, okay. Okay, we can transfer also from our, yeah. Let's say I want to transfer actually from, let's just say from FSX, right? File system, choose file system in this location. Okay, no, we don't have that one. So let's choose S3. Okay, I will check my S3 buckets. I said this is what I want to transfer. I want to transfer this account. Okay, I'm going to choose this one. Allow S3 access. Okay, fine. Next. Location type. I said S3, right? So storage class, keep it. Okay. You can also specify the storage class you want to transfer it to. So I want it to be transferred to standard, or just the standard. Keep it like that just for now. It will not charge us. So we can go here, choose the allow S3 access. you have two options here. You have transfer virtually limited, unlimited number of objects with advanced metrics, more detailed log, higher performance, basic. Subject to quota, that's it. You have specified the data. Everything I want to transfer there. Transfer, determine whether data sync transfer only the data and metadata. Refer. We can do this and click next, and we can do this basically. Okay, direct connects, we've seen about direct connects, and yeah, we know about it. It's just a private connection, speed up, direct, consistent, low latency, high throughput. Yeah, so when we talk about compute, we have topics like reserved uh, instances for 24/7 predictable workload. Okay, cost saving. Okay, we use reserved instances. Yeah, obviously. Let's say we have an instance that we're using like 24/7 and it's the workload is predictable. So it's better to use just reserved instances, right? And if you have like this for fault tolerant and stateless interruptible batch jobs, most cost effective is spot instances. Okay. And saving plan compute, flexible commitment across instance families. Okay. And scheduling, scaling, proactively scale for predictable traffic, like every Friday, this one. Target tracking, reactively scale based on real-time metric. Launch capacity 30 plus minutes before forecasted load. Yeah. So let's let's go ahead and talk about EC2 pricing options. These are pricing options of EC2. So we have reserved instances, something called reserved instances. This is what you use in production, like if you have a steady, predictable workload, like 24/7. Okay, you commit for 1 or 2 or 3 years. Okay, this gives you big cost saving versus on demand. It's better than on demand because you will need it like always on applications, like for backend services or something like that. We use reserved instances. So you need this to be on every time. All the time you use reserved instances. You don't need it if you don't need something to be on or available to be used every time. You can use spot instances. Spot instances are just spare capacity that AWS provide that they don't need, they're not using. This is provided for cheaper price. But the issue with this is they can actually stop your instance or terminate your instances anytime they like. AWS basically. It's up to 90% cheaper, can be interrupted anytime. Focus on this one. They give you 2 minutes warning, that's it. And then they interrupt. That's it. That's spot instances. It's cheap, okay? And yeah, very cheap, but also it's on demand. Yani if something you need it temporary and you don't need it to be always on. Saving plan, this is basically like reserved instance, except it's more flexible. Okay, here reserved instances you can have only, let's say, reserved instance based on the region, specific region you choose, based on specific instance type you choose, and specific instance only, right? This is reserved instance. But here in saving plan, I can have like I can commit for this much dollars per hour usage. That's it, per hour. Basically, let's say I will pay $5 per hour. I can, I can, uh, I can have different instance type. That's okay. Uh, it can be different instance families, different regions. Okay, even AWS Lambda. It's more flexible than reserved instance. Same idea, but more flexible. As long as I don't exceed my usage, which is, say, if I pay $5 per hour, it doesn't have to be one type of instance that I specifically. I can do anything, any of those things. Capacity reservation is on demand. Okay, it guarantees capacity in specific availability zone. Okay, not long-term commitment required. No long-term commitment required. Okay, basically you are guaranteeing capacity. So the difference between from capacity reservation and reserved instances, reserved instance equals to cost saving for cost saving, capacity reservation for capacity guarantees. Okay, that's the difference. Okay, auto scaling type, we have scheduling scaling, scale based on known patterns. Okay, like traffic spike every Friday, then proactive but fixed schedule. This is the one thing. Dynamic scaling, target tracking, automatically adjusts capacity based on metrics. Example, keep CPU around 50%. Uh, this is actually the most commonly used policy. Okay, dynamic scaling. Okay, uh, we said scheduled scaling is scale based on known patterns. Like if we already know that every Friday we're going to have traffic spike, then we can make a fixed schedule like every Friday to scale, right? And with dynamic scaling, automatically adjust capacity based on specific metrics we set. Okay, target tracking. I think we've talked about this one actually. Um, for example, we can say keep CPU around 50%. Okay, like if the CPU is like more than this, something more than 50% or something, then we can just reach more than 50% or something. Then you can add another additional instance, right? That's the idea of target tracking or dynamic scaling. Predictive scaling, this is using machine learning to forecast traffic and launch instance ahead of time. Example, 30 minutes early. Best for consistent traffic and patterns with variations. So other advanced EC2 features, we have placement groups. This controls how instances are placed physically. Okay, focus this one. Like, for example, let's say we have a cluster. If we use cluster, that means low latency, high throughput, same rack. Okay, if you want to place your instance in the same rack, okay, you can use cluster. Spread, if you want to put it in different racks or different hardware, your actual instance physically it means the physical server instance physically. So you can use spread. Okay, cluster is for performance. Okay, spread is for fault isolation. It's the two different placement groups. Okay, and warm pool keeps pre-initialized instances ready, reduces scale-out latency. Okay, hibernation saves instances, RAM to disk, and stops it. Resume very fast startup with same state. Useful for stateful workload needing quick restarts. This is just to reduce the time it takes for your instance to start. Okay. Warm pools and hibernation. So we have to understand these things. When we say spot, it means cheapest but interruptible, right? Because AWS can just terminate your spot instances anytime they like. Reserved instance versus saving plan, flexibility. We said saving plan is flexible, and the reserved instance is specific. You can only have one type of instance, one type of region, specifically, right? Schedule versus predictive. We said that schedule is fixed time, predictive forecasts the future. Capacity reservation is not equal to 7. Yep. So the cheapest, so reserved instance is cheapest for predictive workloads. Spot instance is cheapest overall, interruptible. Saving plan flexible, cost saving. Schedule scaling based on time. Dynamic scaling based on metrics, based on forecast. Guarantees capacity. They reduce startup time. So, so the idea here is saving plans. You're not committing to specific instances. You're committing to spending certain amount per hour. Okay, like I promise to spend $10 per hour on compute for 1 to 3 years. AWS then gives you a discounted rate on whatever compute you use. You commit to $5 per hour. You can run EC2 today, or Lambda tomorrow, different instance type next week. As long as the total usage is equals to $5 per hour, you get discounts. Okay. Because when we talk about reserved instance, you're locked to a specific instance type and region. You cannot change this one. When we talk about saving plans, it's flexible across instance type, regions, and services. So capacity reservation, we said AWS guarantees instances will be available when I need it. Okay, why it exists? Sometimes AWS might not have the capacity in an availability zone during traffic spike or large deployment. So capacity reservation locks capacity for you in advance. You reserve 10 EC2 instances in AWS. Even if AWS runs low, you can still launch those 10 instances. That's the idea. Okay. So dynamic scaling, we said that target tracking automatically adjusts EC2 instance based on real-time demand. So, like you can define a target like CPUs equals to 50%. Then auto scaling will add instances if CPU is greater than 50%, and minus remove instances if CPU is less than 50%. So that's the idea. Then if CPU drops back to 40%, for example, auto scaling removes the instance. So if it is greater than 50%, adds more instances. That's the idea. It's fully automatic, no scheduling needed, nothing. So I hope this is clear. And yeah, already we talked about most of these things. We're just reviewing it now. It's the final review. So see how much time we have now. Okay, we have a lot of time. It's okay. Now that we finished this stuff, okay, now let's go ahead and talk about Lambda. AWS Lambda, we said it's best for event-driven, short running, less than 15 minutes, variable workload. Okay, AWS Lambda is just a function code, like you run it, triggered based on an event that happens, like a specific event happens, like someone uploads data to your S3 bucket, and it triggers AWS Lambda to do something. Same thing with the API gateway, like that. SQS as event source decouples Lambda from S3 events for durable asynchronous processing. From S3 events for durable asynchronous processing. Provision concurrency, pre-warm Lambda function to reduce call start latency. Lambda snapshot reduces call. So the idea of this is basically, yeah, when we talk about Lambda, we said that this is a serverless compute service that runs your code and responds to an event and automatically manage underline. Yeah. So event-driven means it can be triggered by S3, DynamoDB, Kinesis, SQS, API gateway, whatever. Its execution is maximum runtime 15 minutes per invocation. Automatic scaling. It scales per request, no provisioning required. It provides different languages like Python, Node. Pay only for compute time used per 1 ms and memory allocated. So direct S3 Lambda triggered synchronously by S3 event. Object created. Rows by S3 events. Object created. Rows immediate response. Cons no buffering spikes. Overwhelm Lambda. Retries limited. Failure handling can be tricky. To Lambda. SQS acts as a buffer queue. Lambda polls the queue synchronously. Or a queue. SQS is just a queue basically. Lambda polls the queue asynchronously. Like you can configure trigger in Lambda to wait to you can configure SQS as a trigger for Lambda function. Create a Lambda function. When someone pushes something to the queue, takes it, Lambda does some action. Event bridge triggers Lambda in response to event from multiple AWS services. Rows. If you have multiple AWS services, you can use the event bridge instead of SQS. And we have something called cold start concurrency. Lambda function can have cold start when invoked after inactivity. So Lambda container must initialize runtime plus your code. Just to reduce cold start. You can keep Lambda pre-initialized and ready. This reduces latency to near zero. And it's useful for latency sensitive API, enterprise, production app. You pay for pre-warmed instances. Snapshot is pre-initialized Java Lambda, and snapshot at deployment. Cold start becomes almost instantaneous, only works for Java 11 runtime. We have scaling, throttling. Lambda automatically scales horizontally by creating more instances as requests increase. No need to provision capacity. No need to provision capacity. Yeah, it's automatic. Limits per region default 1000. Car request limits and stuff. So basically, I think we already know about Lambda, so we don't need. But we can just have a look at it once. We can just type Lambda here. We dedicated a video special for Lambda actually before. So these are my functions. Basically, think of them as functions. We create a function here. If you want to do it from scratch, you can choose here, but I want to do it using a blueprint. Blueprints, you can choose from here what type of function you need. I just need a hello function, and just keep it like that. Choose any name here, doesn't really matter. So this is a function that gives you this output. Okay, you can create the role and you can create the function here. So once you create a function, here, it's going to give you the output here. This is just a function, starter AWS function, and to run the code here, and you can test it from here also. Like you can test something here, ever test it, see what it says. Value 1 is that's it. So this is the idea of Lambda. I don't want to go through it again because already I think we went through it before. So going through it again is not going to help us. Just understand the concept behind it, and you will be fine. And yeah, we said snap start is only used for Java functions. Provision concurrency is pre-warms Lambda functions for us to reduce cold start latency. And SQS as an event source decouples Lambda from S3 events for durable asynchronous processing. Containers, we've talked about containers as well. Containers are just, yeah, we have different types of containers. We have ECS and we have EKS. Let's see how much is remaining. Yeah, we have containers. We have Amazon ECS with AWS Fargate. We've talked about this. This is serverless container, no infrastructure to manage. Yeah, this actually speeds up. We don't need to use EC2 instances in this case. We don't need to put servers, so we don't need to manage anything basically. It simplifies our job for us. And EKS is Elastic Kubernetes. It's use of containers creation with standard tooling. We use this one basically if you want to use Kubernetes. Okay, ECS is Amazon specific. Kubernetes is if you want to use Kubernetes to manage and provision containers. It's used for container orchestration with standard tooling. AWS App Mesh or Load Balancer Controller. Service Mesh for EKS. Use ALB for routing. Uh, okay. This is for EKS. Okay. Routing. Okay. It's a controller for load balancing basically. Use App Mesh. And database RDS, Aurora, DynamicDB, DynamoDB, and Elastic Cache. Okay, we know that we know this multi AZ. It's just multiple availability zone, right? For high availability and automatic failover, synchronous replication, we use multiple AZ. We know about this one, right? You can set multiple AZ and you configure RDS, Aurora, or DynamoDB, or whatever. And read replicas, we said that this offloads read-only traffic, okay, reporting from your primary DB. You have one DB that's used for write mostly, and you can have 2, 3 DB specific for read, only read replicas. You can do this setup only if you have, like, let's say you have your application or your systems are actually just mostly focused on reads, the writes. And this is the idea. You have 1, 2, 3, 4, 5, 6, 7. These 2 questions you have like a lot of questions related to this too. And for unpredictable intermittent workload, auto scale capacity, we have Aurora serverless V2. This is used for unpredictable intermittent workload, like auto scale capacity. Okay, so we use Aurora serverless. Aurora global database. This is used for cross-region disaster recovery with low latency, replication, and fast promotion. Aurora auto scaling automatically adds or removes Aurora replicas for read-heavy workloads. Okay, and RDS blue-green deployment, safe production-ready database upgrades. Okay, safe production-ready database upgrades. RDS custom for application needing OS level access. I think this is pretty straightforward. Okay, we don't need to go into details. Yeah, you said Aurora serverless. This is new for us, but we said V2. We use it for unpredictable intermittent workload that provides autoscalers. Global database, we said if we need cross-region disaster recovery with low latency replication and fast promotion. Auto scaling, it just auto scales automatically adds or removes or replica for read heavy workloads. DynamoDB, it's on demand capacity for unpredictable spiky traffic, no capacity planning. We use on demand capacity. Okay. Uh, DynamoDB Accelerator or DAX. It's in-memory cache for microsecond read latency. Okay. And we have DynamoDB global tables, multi-region active-active global consistency. Okay, DynamoDB streams captures items level changed in real time. Okay, if you want in-memory cache, microsecond latency that's compatible with DynamoDB, then you use this one, accelerator. Okay. Multi-region active-active globally consistent. Use global tables. Elastic cache, we said this is like for Redis, we have in-memory data store for session management, distributed sessions, write-through scaling, write-through caching, updates cache immediately on DB writes to ensure consistency. So we have database migration also, we have AWS database migration service, minimal downtime migration with ongoing replication. We have AWS SCT, converse database schema, yeah, RDS proxy managed connection pooling reduces Lambda call start and connection timeouts. AWS Secret automates database credential rotation. So actually, so let's continue networking and content delivery. We have VPS gateway endpoints here. Uh, yeah, we said that endpoint is just let's say you have a private instance or uh, something you don't want to give it internet access, right? Since you don't want to give it internet access, you can use VPC gateway endpoint. But you need it at the same time. You need it to access S3 or DynamoDB or this other AWS services, right? So you can use VPS gateway endpoint. Yeah. Yeah, this is this has a lot of questions, and this is actually very simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This has 13 questions I found. Okay, VPS gateway endpoint. The idea is you have a private instance and you want to access AWS services like S3 and DynamoDB from those instances. Okay, but since if this was public, if your instance, let's say your EC2 instance was public, you can access the services, right? Easily. If yeah, but it's private. So since it's private, there is one way you can do. You can add like you can link it with the NAT gateway. Like you can have internet access, but it will require internet access. So you don't want to give internet access to this instance. Okay, you just want to access this AWS services. You can use VPC gateway endpoints. VPS interface endpoint. This is private access to other AWS services like SQS, API, and gateway. Okay, and private access to other AWS services. VPC peering. This connects to VPC within the same or different regions. Okay, yeah. Let's say you have two different VPCs on different. They are on different regions. Okay, or it could be same. It doesn't really matter. But you want to connect them. You want the instances inside these VPCs to communicate with each other. So you can use peering, VPC peering. Okay, AWS Transit Gateway, central hub to connect hundreds of VPCs on an on-premise network. Okay, Transit gateway is like the same concept of VPC peering, just that VPC peering is only for two VPC. Okay, two. That's it. It will work well for two VPCs. But let's say you have uh, five or six or more like that. You cannot use VPC peering. You have to use VPC AWS Transit gateway because you will have a central hub to connect hundreds of VPCs and on-premises networks. Central hub, that's the feature available in Transit Gateway. NAT Gateway, this is a managed service for private instances, yeah, to access internet. Yeah, this is what I told you before, right? We can configure NAT Gateway, okay, and connect it to private instances, to basically private instances, okay, will allow you to access internet outbound only, okay, and this is the questions. We have like a lot of questions on this. Egress only internet gateway, outbound only internet for IPv6. Egress only internet gateway is only for IPv6. Okay, and route 53 we have route 53 is DNS. We've talked about this. In geolocation routing, this is route based on user geographic location. Okay. Yeah, latency routing routes to the lowest latency endpoints. This is easy. And failover is routes to healthy endpoint, failover to disaster recovery. So this is also easy. You can have two in different instances. Configure route 53 just to one instant. Once one is down, you can move to the next one. Multi-value answer returns multiple healthy IPs for simple client side loading. So CloudFront is like CDN basically. CloudFront plus S3 origin. This is used for global caching for S3 static websites. Yeah, plus S3 origin. This is global caching for static websites basically. Yeah. CloudFront plus ALB origin, cache dynamic content globally. So this are the two differences. See, CloudFront is just used to create distributions or CDNs. Okay, you can configure it with S3 or ALB. S3 if you need a static website, since you can only host static website in S3, right? But if you need ALB like this, cache dynamic content globally, like content that changes, like based on the the change, then you should use the cache dynamic content globally. CloudFront plus ALB. So origin access identity restricts S3 access to only CloudFront. Okay, origin access identity, like you can restrict S3 access to only CloudFront. For example, you can put S3 in private, basically, but you want this S3 to be accessed using CloudFront. You can use this one, origin access identity. Lambda edge run code at the edge location for device specific content, authorization, resizing. Field level encryption protects sensitive data through entire application stack. Geographic restriction blocks user from specific countries. Global accelerator low latency routing over AWS global network. Static IP supports UDP health check. So before we move on, let's go ahead and see this one first. Just let us 1 second. Okay, let's just have a look at CDNs, CloudFront. Cache zero content at edge locations globally, reduces latency. S3 for static websites, ideal for static websites basically. And ideal for static website, yeah, S3 origin, cross global flash caching, faster load time, reduce direct request to S3, cost saving, and ALB and EC2 origin caches dynamic content from application servers. Uh, can cache parts of dynamic projects, reduces load on origin servers. Access control, we have origin access identity and origin access control. This restricts S3 bucket access, so only CloudFront can access content. And prevents direct S3 URL access. So origin access identity is old actually. Right now we have origin access control. This is the recommended new method. Lambda Edge run custom code at edge locations for device-specific authorization, resizing, optimization, access control. This reduces latency. No need to process requests at origin. Lambda Edge function can manipulate request response header cookies content. So field level encryption encrypt specific field of sensitive data and request. Example, credit card number for submission. Ensure end-to-end encryption from client, CloudFront to origin. Geographic restriction blocks user from specific countries to allow only selected country useful for compliance or licensing restriction, basically. And yeah, AWS Global Accelerator improves performance availability by routing traffic over AWS Global Network rather than public internet. Key feature static IP, same IP of your endpoint globally. Low latency routing routes to the optimal AWS region. Supports UDP and TCP. Health checks. Automatic failover for healthy endpoint. Use case global applications needing fast, consistent response. Multi-layer failover. Faster recovery. Gaming. So this is the key concepts that we need to know about this. And I think we should have went through, and we did. And we have now security, identity, and compliance, where we have IAM roles for EC2 and Lambda. IAM roles for EC2 and Lambda basically grants permission for instances, functions without hard coding keys. That's the idea of IAM roles. Like, yeah. Instances and functions without hard coding keys. IAM roles for cross account access use a role or trust policy to delegate access. Yeah, you can do this. Service control policies, centralized permissions, guardrails in AWS organization. You can have SCPs. Okay, IAM policies with AWS principal orange ID restricts packet access to users in your AWS organization. Restrict access to users in AWS organization. IAM password policy enforces password complexity and rotation for all users. So this is actually pretty straightforward. I think we went through it also before, so we don't need to. We just understand this too. And this is this three. These are the key where we have a lot of questions coming from those three. We know that roles are just you can use roles when you want. For example, let's say I have an EC2 instance. I want to access S3 from my EC2 instance. I won't be able to access it if I don't have roles. If I don't assign IAM role in the EC2 instance to allow S3 access, then only I can access access S3 from my EC2 instance, right? Same thing goes with this. So network security, we have WAF, Shield, and Firewall. WAF is just protects ALB, API gateway from SQL injection, XSS, and RAID-based attacks, basically. AWS WAF protects ALB, App API gateway from SQL injection, XSS, and RAID-based attacks. Yeah. Yes, and Shield Advanced Shield is just for DDoS protection. Okay. AWS Network Firewall managed firewall for VPS traffic inspection and filtering. AWS Network Firewall, it's managed firewall for AWS Network or VPS actually, traffic inspection and filtering. Gateway Load Balancer deploys and scales third-party virtual appliance. Okay, Gateway Load Balancer deploys and scales third-party virtual appliance like firewalls. Security groups as source and destination. Reference security group ID, not IPs, for at least for least privilege. Security groups, we know about that. Reference security group IDs, not IPs, yeah, for least privilege. Prefix list centralizes and shares the IDR block management. And data protection and discovery, we have Amazon Macy. This discovers and classifies personal identifiable information in history. Guard duty threats detection for malicious activity. Usually calls. Uh, Discovers and classify personal identifiable information. And Amazon Guard Duty threat detection for malicious activity, unusual API calls, or Spectre scan EC2 instance for vulnerability. Certificate manager provisions and manages self-certificate automatic renewal for DNS validation. These are the things that could just so these are the main things. So personally identifiable information, like any data that can identify you specifically, basically like full name, phone number, email, whatever. Information the app collects because the data is sensitive. So basically, discovers and classify personally identifiable Macy and guard duty, malicious activity, and ACM. We said that AWS Certificate Manager provisions manages SSL certificate, automatic renewal, and DNS validation also. Lar Tawhid, Lar. We have three or what? Yeah, I think this is straightforward. Analytics and big data. We have Amazon Athena. We said Amazon Athena just allows us to run SQL query directly on S3 objects buckets, right? QuickSight, this is BI dashboard and visualization. And streaming data, Kinesis data stream, real-time data ingestion with ordering and reply. Kinesis data firehose, load data streaming into Redshift, S3 or Redshift. Yeah. Data analytics, real-time SQL on streaming. Managed Kafka for presentation. Just focus on this two, mostly because they're coming. You got a lot of questions coming from those two actually. Amazon Kinesis data streams. This is real-time data ingestion with ordering and reply. Okay. Amazon Data Ware Firehouse loads streaming data into S3 or Redshift. Big data processing, we have AWS Glue. This is serverless ETL, CSP to Parquet or something. Glue crawlers automatically catalogs S3, Hadoop, managed governance and cost optimization. AWS Cost Explorer analyzes cost filters by service tag or instance type. Cost anomaly detection alerts on unusual spending. Budget threshold and sends alert. This budget. User-defined cost allocation activates tag in billing. Flexible cost saving commitment across any compute service. So we have here uh, so AWS budget, we talked about it the first session. Just basically it's just you set the threshold and send alert when AWS exceeds this threshold. Post anomaly detection alerts on unusual spending, like Cost Explorer analyze cost filter by services, tags, instance type. All this can be done using the Cost Explorer. And user-defined cost allocation tag activates tag billing console for detailed reporting. Flexible cost saving. Compute saving plans, we've talked about it also. Flexible cost saving. So here we have resource and config management. Okay, we have AWS config. This tracks configuration changes and audit change against tools. Example S3 public access. Okay, tracks configuration changes and audits against rules basically. S3 public access. Yeah, and CloudTrail record API calls for auditing security analysis. System manager use for secure remote access, no bastion host. You can use system managers, run command for patching, parameter store for secrets. This is AWS system manager. AWS resource group or tag editor find resource across accounts, regions by tags. And AWS control tower automates multi-account setup with guardrails, detects organizational individual. Service catalog, centrally manage and deploy approved IT services. And this one is important, AWS backup, because you get like a lot of questions here. Centralized backup management with lifecycle policies across region. Copy, this is AWS backup. EBS lifecycle manager, ELM, automates EBS snapshot, creation and deletion. This is EBS lifecycle manager, ELM. So incident alerting, we have Amazon Event Bridge, Cloud Events, CloudWatch Events, Schedule Task, Stop, Non-Stop, React. Yeah, if you have more than one, if you want to interact with multiple AWS, we have CloudWatch Events, Amazon CloudWatch alarm based on multiple parameters, metrics like you can say CPU greater than 50 or high reads, all this stuff. AWS Trusted Advisor access RDS optimization check. Application integration. We have SQS standard queue. This is high throughput. At least once delivery decouples component. Okay. This is first in, first out queue. Guarantees first in, first out processing exactly once. SQS dead letter queue retains failed message for analysis. SQS visibility timeout prevents duplicate processing, increases timeout if processing is greater than 30 seconds. SNS fanout publishes message once, delivered to multiple SQS queues for multiple consumers. Before fanout message to multiple subscribers when preserving order. Hybrid and edge, we have single digit millisecond latency for edge application close to major cities, AWS local zone. Outpost run AWS services ECS or RDS in your premise data center, on-premise data center. So for summary, we have here just understand this is the final review and we finished it, and that's it. We just have to go through it every once in a while, practice, and that's all actually. If you master these things, these questions, these topics, and you practice it manually, 10K on the labs using AWS free tier, I think you can pass the exam, right? Thank you for watching and see you on the next course.